Welcome, this is 2.8, modeling two-variable linear equations or inequalities. We have a situation this morning that we're trying to solve. The Band Booster Club is selling t-shirts and blanket wraps to raise money for a trip. The band director has asked the club to raise at least $1,000 in sales so that the Booster Club can go on this trip. That's what it's going to cost them. So they set a fundraising goal of $2,000. Now, they talk to a company and they find that they can sell t-shirts with a cost of $10 each and blanket wraps for $25 each to help make this goal. So we want to write an inequality for this. So we would think to ourselves, well, if we go back to unit analysis, we have $10 per t-shirt. So if we multiply that by the number of t-shirts that we sell, then we can see we would come out with the dollars that we raise from t-shirts. So to write our equation, we would have 10, let's just call the number of t-shirts x. So we should define that variable, x equals number of t-shirts. Sold. And then we'll take 25, same type of a unit analysis. It would be $25 per blanket times the number of blankets. Because we plan to graph it, we'll say 25y, y being number of blankets. And we are asked here to write this expression into an equality, a linear equation, to equal our goal. Our goal was $2,000. So we now have our equation that we can look at. So as we're at the meeting, people start saying, okay, well, what if we sell 50 t-shirts? Can we just sell 50 t-shirts and 50 blankets? Being the math student you are, you could plug that in. 50 t-shirts would be 500, 10 times 50. And 50 blankets would end up being $1,250. If you multiply 50 times 25, it's $1,250. And people are saying, will that be enough to make our goal? $1,250 plus 500 would be $1,750. So you could immediately reply, no. 50 blankets, 50 t-shirts isn't enough. So they're trying to figure out how many to order. They say, well, let's double that. Let's make it 100 t-shirts. Well, now you know that you're talking $1,000 from t-shirts because 10 times 100 is 1,000. So you can tell them, well, if you order 100 t-shirts in order to make our goal, how many blankets do we need? Well, we need to make 1,000 there as well. So you would end up needing 40. So we'd have $1,000 from that, and that would make our goal. So if we order 100 t-shirts, need 40 blankets. And that's how you can figure it out right there at the meeting. Oh, I just did that problem. So that would help you there. Now, it may also be helpful if you just take this equation, the 10x plus 25y, equals 2,000. that's your goal. It might be helpful just to go ahead and graph that. So in graphing that, we pretend x is 0, and we solve for y. We would have to have 80. Okay? So if we make y our number of blankets, please always label the axis and always look at axis to see what they're labeled. X would be number of t-shirts sold. Now, if we have 0 blankets sold, 10 would go into 2,000, 200 times, so we'd need 200. We'll just go by tens here, so that would be 10, 20, 30, 40, 50, oh, I'm sorry, we'll go by hundreds. 100, 200, 300, 400, 500, there's 1,000, there's 2,000, and let's see, we're trying to go 200, 100, 200, I'm on the spot, I've got to make sure, no. I did go by 10, so this would be 10, 20, 30, 40, 50, 100, 150, and 200. Okay, so if we sell 200 t-shirts at $10 each, we make our goal. Now if we go up here on the blanket side, we go by tens again. 10, 20, 30, 40, 50, 60, 100, and we know that we need to sell 80 of those. Now, I also calculate another point, as you know, so if I go 50 t-shirts sold, 50 t-shirts, that would be 500. I'd need 1,500, 25, let me just solve that. 10 times 50 is 500, plus 25y is equal to 2,000. So 25y, subtract the 500 from each side, 1,500. 25 will go into, I just take a quarter into $1.50, that would be 6, so 60. You can divide it out, 25 into 1,500, it'll be 60. So my point is at 50, 60, and those should all be collinear. It looks like they are. I managed this time to bring out a ruler so I can make sure, aha, they are collinear. So right there is our goal. That's our goal of what we want the sales to be. Okay? Now, interestingly enough though, they did tell us that, let me see if I had any other big questions. So what this is saying that if we don't sell any blankets, we have to sell 200 t-shirts. And if we don't sell any t-shirts, then we need to sell 80 blankets. And then all these points in between are showing us, okay, if you sell 50 t-shirts, you need to sell 60 blankets. And all of these points will tell us, any point on the line will tell us how many we need to sell if we sell a different number of blankets than the 80, or a different number of t-shirts than the 200. So that way it's a little bit quicker in your meeting as people are asking, hey, how many do we need to sell? So, let me just pick out a point here. Let's go to 100. And it comes up to 40. In your notes, I'd like you to explain what that point 140 means. Remember the X stands for t-shirts, 40 stands for blankets. Come to class and ask if you're not sure what that means. Okay. Suppose the Booster Club sells 25 blanket wraps. Use the graph to determine how many t-shirts they need to sell. Well, we go up to 25 for the blanket wraps. 10, 20, 25. Come out here. Drops down to about 140 t-shirts. Okay, so that's an easy way to solve it. You could plug it in, but sometimes we just want an estimate. Okay, now they want us to write and graph a linear inequality that shows the sales required to raise the minimum for the trip. Well, if you remember right, the requirement for the trip was $1,000. So we have our t-shirts plus our blankets, and we had to have at least $1,000 to make this trip. Okay? So we can go ahead and we can calculate like we did before. This time, if we don't sell any t-shirts, 25 goes into 1,000, 40 times. So our line would be at 0.40. If we don't sell any blankets, so that one wipes out. 10 and 1,000 would have to sell at least 100 t-shirts. So there's that line. And then I always plug in one more. Let's go to the 50 again. Instead of it being 50-40 to be at 200, does it make sense it would be 50-20? 50 times 10 is 500. 25 times 20 would be 500. So 50, 20. Now again, I should get my ruler, but I think the board would fall off while I lean down to get it. So there is our minimum. Now because that's a minimum, we know we need to sell more than that in order to make our trip. So the way that I suggest that you do that is plug in a point. And I would just choose a simple point out here. Or you could actually try 0, 0. If you don't sell any t-shirts and you don't sell any blankets, you know you haven't met your goal, right? So that shouldn't be a part of the solution set. 0 is not greater than 1,000, so we know that we don't shade this way from that line. Instead, we shade out that way. Okay. Suppose that the manufacturer made an error and no blanket wraps were available. How many t-shirts would you need to sell in order to meet your minimum goal or your minimum requirement? So if you come over here, there's no blanket wraps. So we come over here, we'd have to sell at least 100 t-shirts. Now, what does it mean if we sell 70 t-shirts and say 40 blanket wraps? It lands right out here. What does this shaded area mean? It's above the minimum required to take our trip, but it's below the goal that we wanted to meet. Now, if we're way out here, we exceeded our goal, and we've met the minimum for our trip. I hope that makes sense. The last thing that I want to reinforce to you is make sure when you come to class that you understand how we did the unit analysis here on the variable. It was $10 per shirt, and so we multiplied by the number of shirts, and that shows the units canceled, and we have the 10x. If you don't get that, make sure that you practice that with me or with someone else, and other than that, I think we're good to go. Enjoy yourselves.